exoplanet is a planet that orbits around a star other than our Sun. Some examples include Kepler 186f, 51 Pegasi b, and Tatooine. Researchers at Princeton University, led by Professor N. Jeremy Kasdan, have found a new way to detect exoplanets. In Hawaii, the Coronagraphic High Angular Resolution Imaging Spectrograph, or CHARIS, is attached to the Subaru Telescope. No, not that Subaru. The Subaru Telescope, unlike the car company, is owned by the National Astronomical Observatory of Japan, or NAOJ. NAOJ has collaborated with Princeton in the process of creating and using CHARIS to detect more exoplanets. Although CHARIS was only delivered to Hawaii last May, it has already taken images during several successful field tests, including planets located around a star in the planetary system HR 8799 and vapor clouds around Neptune. CHARIS is open to everyone for scientific research in February 2017 and is showing much promise, especially for observing young disks, star systems where planets are still in formation. Several different methods can be used to detect exoplanets. The most popular method is to use a telescope to monitor the brightness of a star. Any planets crossing between the telescope and the observed star will cause a dip in the brightness of a star. If the dips reoccur regularly, then scientists can confirm the existence of an exoplanet. The size and length of time between each dip can be used to infer the planet's size and distance from its star. An alternate way to detect exoplanets is the wobble method. The gravity between the star and the planet causes small changes in the star's velocity. Changes in the star's spectral emissions can then be detected due to the Doppler effect. The mass of the planet, the duration of its orbit around the star can be determined. In 2018, the James Webb Telescope will join the search for exoplanets. The telescope will detect exoplanets in several different ways. One method blocks light from the star with a small disk in order to detect the fainter infrared glow of the exoplanets. The infrared light from a planet can be used to infer the content and characteristics of the exoplanet's atmosphere. This method is identical to that used by CHARIS. A coronagraph compares the light coming from a star with and without an exoplanetary transit occurring. A spectrograph detects differences in the color of the light, which can be used to calculate the concentration of different gases in exoplanetary atmospheres. The composition of the atmosphere can then be used to estimate the planet's habitability. One limit in CHARIS is its narrow scope. Its field of view is equal to about 2 arcseconds. When testing out the mechanism, only a small part of Neptune could fill its view. However, CHARIS's high sensitivity makes it an important achievement in aerospace engineering and astrophysical research. Maybe CHARIS will enable us to one day find the Death Star.